right, we're going to go ahead and get started. So thanks everyone for joining us. My name is Jen. I work with the OpenDDS team and the OpenDDS Foundation, and we are pleased to have the OCI OpenDDS core team with us here today. We have a full group here and excited to talk with you. Adam, Tim, Justin, Fred, and Soan. Welcome, guys, and thank you for joining us. Today, we're going to talk about getting started as an OpenDDS code contributor. So a few housekeeping things. We will do a live Q&A session at the end and answer as many of your questions as time will allow. As a reminder, please go ahead and load up your questions in that Q&A session. So I believe that's all we have, and I will turn it over to Fred.
Thanks, Jen. Today, we're going to be talking about how to get started as a contributor on OpenDDS and related projects. So whenever someone wants to contribute to an open source project, it's usually an issue of like, you don't know where to start, what's expected of a code contribution, of a PR, of a set of changes, that sort of thing. So we're going to be going over not necessarily how OpenDDS works exactly, but basics of how to get started with the development environment, what kind of documentation, what kind of resources we have available for contributors, and what testing your changes might look like, creating a test. And then finally, once you have that all squared away, what opening a pull request, seeing what the CI looks like. And then finally, we're going to be looking over how to contribute to documentation of the website. And then there's related repos like our dependencies and various language bindings that sit in different repositories. And then after that will be the Q&A. And we can turn it over to, I think it's Soan is this part.
Yeah, I'm going to talk about setting up a development environment for OpenDDS. First, I want to give a quick overview of MVC. So it is a short term for the Makefile project and workspace creator. And it is a tool that is used by OpenDDS to generate input for specific build tools that you use on your platform. For example, on Linux, you probably use GNU, so it will generate Makefiles. And on for Windows, it will generate solution file for Visual Studio. The input for MPC is a file, a common file called WC or MPC file, and this file describes the project being created. Like you can specify whether the output of the project is an executable or a library, or you can also set the include path for the desired header files, and you can specify the dependency of your output, and etc. There are many other options you can use to describe the project. And the key point of MPC is that it allows us to write the common input file like the WC or MPC file once, and then we can reuse that to generate the actual build file for your build tool for different build tool. So if you work on Linux or if you work on Windows, you can reuse the same file, and then it will generate the output depending on your platform. And I included the link to the GitHub repository of the MPC repo, and if you are interested, you can take a look. There is detailed documentation of how to use it. So the next slide, I included an example of using MPC. This is actually a test from OpenDDS called Build into Big Test. On the left-hand side, this is a list of files in that directory. So you can see at the top of the list is the input MPC file for the MPC tool. And then on the right-hand side is the list of files after I run MPC with that input. And you can see on the green box is the list of Makefile. The top level Makefile, there is one top level Makefile, and it will delegate the build step to individual Makefile for your output. So for this directory, there are 3 output monitor publisher and subscriber, and you will have one GNU for each output or target. The same thing, so you can use the same MPC input file, and then if you use Windows, it will generate the same the list of solution file for those three targets. So having talked about MPC, now let's talk about the configure script provided by OpenDDS. So this is a Perl script. We use it, we write and use to configure OpenDDS feature and also download and configure its dependency like a style to generate a build file for OpenDDS and also for the dependency like a style. Using configure, you can, like I said, you can download the dependency and configure it using the configure script, or you can specify existing the path to existing dependency, existing A style MPC that you already have in your local machine. Using configure script, you can enable and disable OpenDDS feature IP. You can turn on IPv6 and turn on security feature. You can specify if you want to build a static, to build OpenDDS as a static setup library, and you can specify that you want to build OpenDDS test, and internally configure script you MPC to generate the build file, like generate GNU files, Visual Studio, solution file, and so on. To look at the detail of the available options provided by configure, you can run it with the have option. After running configure script, there are two kinds of output. So the first one is the build file that are generated by MPC. Using this build file is like OpenDDS is ready to build. You can run make on Linux, for example, to start building, or you can run solution file on Windows. And the second the second output of configure is the set environment script. So it is set and .sh on Linux and set and .cmd on Windows. This script contains the environment variable required to compile and run OpenDDS test. So for example, Linux, you may want to run set environment script before running Mac or running OpenDDS test. So I added two examples of using configure script. The first one, you specify that you want to use ACE Entile, the latest ACE Entile source code from its GitHub repository, and then configure it. And also using this option, it also download the MPC for us. The second option tell the configure script to configure OpenDDS to enable IPv6. And the second example, if we already have a style and MPC in our local machine, we can specify the path to those dependencies, and then configure will use those dependency A style and MPC instead of downloading it from its repository. And also in this example, we specify that we want to build OpenDDS with security and also build on OpenDDS test, including unit test, integration test, and performance test. And also example. One thing, noteworthy thing is that after we run configure once, the second run of configure may not work as expected because the first time it run, it writes some feature configuration file that may not be overwritten when we run the configure the second time. Two options we can do here is create a new clone for OpenDDS and run configure over there. Or the second option is to delete all generated file using git clean, and after that on the generated build files and also the feature configuration file will be deleted, and you can run configure again. So I haven't talked about configure and MPC now, I will talk about how we the step we can use to set up OpenDDS on Linux or Mac OS. So first, open the terminals window, and then we clone OpenDDS from either the original the object computing account, or you can fork OpenDDS to your personal account and then clone from there. And then the second step is run configure script with your desired features. And this photo show the layout of the OpenDDS folder. After you run configure script, you can see that a couple of GNU Makefile, top level GNU Makefile, and then a set environment script. The next step is run set environment script to export the required environment variable. But you may not need to, but you don't need to run that if you run from the top level directory. So if you go directly inside OpenDDS, then you don't need to run set environment script. So lastly, you run make to build OpenDDS. For example, make task J4 to run it with ForTOS. So for Windows, it's a little bit different, but like basically it's the same step. So you open the command prompt for Visual Studio, either x86 or 64, depending on what version you want to build. And then you clone OpenDDS to your local machine, and then run configure script with your wanted features, and then run set environment to export the environment variable. And after that, it will generate the solution file in OpenDDS directory, and you can open that file from the same command prompt, and then it will launch a Visual Studio window. And on the Solution Explorer tab, you can right-click to the browse like the collapse option, and then you can click and choose Build Solution, and it will be OpenDDS. And lastly, it is worth noting that OpenDDS also support other platforms like Android, iOS, or Raspberry Pi. I added a couple of reference here in case you are interested in learning more about that. So those reference include steps to build OpenDDS on Android, iOS, or Raspberry Pi. So with that, I will hand over to Adam for the next topic.
I'm going to take us through a quick guided tour of some resources. So the idea here is that you've gotten the development environment set up, as we just talked about, but there's a lot of information now, and that may be overwhelming for someone who's relatively new to the project, especially from the contributor maintainer point of view. So starting with just a screenshot of the main contents of opendds.org/documents. So things that are kind of outside of the code that you've just cloned and are seeing on your in your development environment, we'll have links to. So at the top there, the various object management group specs that OpenDDS implements. So important to reference those if you want to know why things work a certain way in the wire protocol or the DDS APIs, type system security. So all those things are available. Below that, other documents that are provided by OpenDDS project itself are things like the developer's guide. And the main focus of the developer's guide, what do users of OpenDDS need to know to build their applications? We'll talk a little bit more about developer's guide later in this presentation, but just keep in mind that that's there both to help you, and if you're contributing a new feature, keep in mind if you'd like that new feature to be documented in the developer's guide. And then the other one that has a call out there is the building, and that's just a page on the website. And the website content itself is managed in a separate branch within the GitHub repository. So the building page is what do users need to know to actually build, to compile OpenDDS. So things like the supported platforms and compilers are listed there. That may change, and if you need to edit it, that is available for editing as well in the GH Pages branch of GitHub repository. So next, let's take a look at the actual directory layout within the repository that you've just cloned. So over on the left margin, I've shown the top level directories that you see within the repository. And there's a lot there. So this is one of those things where it may not be structured like other open source projects, and it may be a little bit overwhelming, the amount of information here. So depending on what you're looking at changing in the repository, you may be interested in, for example, tests that's near the bottom on the left. And we'll be talking a little bit more about tests in a moment. But you can see there are the different directories there at the top level for things like the Java bindings have kind of its own, Java directory. So some of the in repository documentation there in docs. But where we have the arrow drawn here, you'll see is this lowercase DDS. So this directory, lowercase DDS, kind of contains the implementation, the main implementation of OpenDDS, all the various parts. So if you go within that directory, we now have this next column listing here. At the top, it has some kind of rarely used directories to help adapt to different Corba types and help with safety profile, which we don't need to spend time on here. The main one we might want to look at, though, is these capital DCPS. DCPS is data-centric publish and subscribe, and that will have the main implementation of libraries that are used to build OpenDDS applications. Below that are different parts of the system related to kind of other features. Face we're going to not discuss here, but we can get to later if we need to. Info repo, however, is the DCPS info repo. So that's the discovery server that's provided with OpenDDS. Then below that IDL is the implementation of the OpenDDS IDL backend, the code generator. You'll see also files at this level. So these are mostly IDL files that come from the DDS specifications. So this is where the types that are specified by the APIs, so things like, what is the data writer interface, right? What operations can you call on it? What is the domain participant interface? Those are all found in those IDL files. The next layer in, so we're looking within the DCPS directory, and we see this third column here of folders like info repo discovery, QoS XML handler, RTPS X types. These are all kind of individual libraries and components that make up OpenDDS. So info repo discovery, as opposed to just the info repo before, which was the server, info repo discovery is the library that clients can use to talk to the server. And there are things like the RTPS library, which contains the RTPS discovery implementation and other features from the RTPS specification. And you see the other implemented specs like X types and security there. And transports are all grouped together, so they have their own next directory level down. And I've shown a few files at the bottom of this, address cache.h, association data.h. There's many, many more. These are kind of the main files that get built into the libopenddds DCPS library. And then finally, on the right-hand column, within that transport directory, there's a framework directory, which are source code files that are common to or could be used by any of the transport types. And then there are the individual transport types that are supported. So that's a tour of just parts of the OpenDDS source code repository, but maybe the parts you'll encounter. So let's go ahead, and the last thing I'm going to discuss in the guided tour is to especially call out the development guidelines. So this is a file in the repository under docs internal dev_guidelines.rst. And this is the style guide. This is the what we've all kind of agreed on for conventions and how we want to author and maintain the code going forward. So it especially touches on topics like interacting with external dependencies, how date and time data types are handled, and how logging and the log levels and debug levels work. So with that, I will turn it over to our next speaker, who is Justin.
All right, so I'm going to talk about testing in OpenDDS. So as you're contributing code, we obviously, you want it to be correct. We also want it to be correct. OpenDDS contains 4 kinds of tests. There's unit tests, in which we're exercising a specific source code module. And think of this as a some kind of prefix and its associated .h or .cpp or .inl file. And these are located in your DDS root /test/unit tests. There's also integration tests where we're typically exercising a feature typically in an end-to-end way and in a semi-realistic fashion. So in our integration tests, you're going to see participants and data readers and data writers created just like a real application, but perhaps with without some of the error checking that you would do to be more clear. But they're typically exercising a particular feature that you want to see. And these are located in DDS root tests and Java tests for the Java bindings. There's also a group of tests where we attempt to stress a particular component or feature. So the stress tests live in test stress tests, and they may look like a unit test or they may look like an integration test, but their purpose is really to do the same thing over and over again, hoping for a different outcome. And we typically write those whenever we think there's a problem with non-determinism or ordering or something like that. And the final one is performance tests. And this is really a test to measure the end-to-end performance. These tests are located in DDS root performance test bench. There's a presentation on or a webinar on this a while back. In this particular talk, we're going to focus on the unit tests and integration tests, as most contributors aren't going to be writing stress tests or performance tests as part of contributing to the code. So to add a unit test, you pick the source code module that will be tested. So if you're creating a new module, you'll need to create a new unit test. If you're just editing an existing module, the test may exist or may not. So in any case, if your module is DDS root, DDS, DCPS, disjoint sequence, then you will create a unit test file using the same kind of prefix structure. So that would go to DDS root tests, unit tests, DDS, DCPS, disjoint sequence, CPP. You'll then run MPC to add the new file to the make files, and then you can start writing your tests. So unit tests are made using the gtests and gmock from Google Tests. I won't spend really any time here. If you want more information about that, there's certainly documentation on the internet available for those. But a basic test looks like, has the following form. You use this test macro. There's a test suite name, a test name, and then you have the body of your test where you're typically setting something up and then exercising it, checking it, and then tearing it down. The test suite name is important and should match the path to the source code module. So as an example, following the example that we have, we take the DDS, DCPS disjoint sequence, and then we convert the slashes to underscores, and that gives our test suite name. The reason that's important is because those unit tests then get attributed to the code coverage testing that we do. So the reason being is that we know that a developer intentionally wrote a test that covered this code as opposed to it just being included from some other test. The test name is less important, but it should just be descriptive so that as you're looking at test results, you know what test passed or failed, and you can go find it. After that, you're obviously going to build your test using the build tool chain that you're using either on Windows, Linux, or Mac. Before we get to running them, there's just a few details. One is that if the source code module you're testing is conditionally defined, then your test should also be conditionally defined. Otherwise, you'll run into, you'll look at the CI in GitHub Actions, which Tim will talk about later, and it'll complain that your code isn't there. So that's just one gotcha. Another gotcha is that all the tests are combined in a single executable. So you should use anonymous namespaces for scoping. I have seen compilers that didn't appropriately link, and that caused some very weird test results. So be aware of scoping and that it's combined into a single executable. And you can see the internal documentation that's noted there if you want more information about writing unit tests and the rationale behind it. So after you have your unit tests in place, you can run them. You can either execute the unit tests executable directly and pass the gtest filter test case name to run your specific tests. The entire unit test executable takes maybe 5 seconds or maybe a little bit more right now. It's pretty fast. So I often run all the tests all the time when I'm developing. You can also run the Perl wrapper around that that's given on that second line. And if you have a coverage build, you can also run this unit test coverage script, and that takes a very long time. It runs the executable once for each source code module and then compiles a report. And the same report is available on our scoreboard, and I think we'll talk about that later. So for integration tests, in this test directory, there's a number of subdirectories for different things. And the main one we're going to focus on is DCPS. There's the other one you may be interested in is transport if you're mucking around with the transport, but most contributors are probably going to start in DCPS. So that's the directory, where all the tests are. So to add an integration test, there is a hello world that is really a good starting point for adding your own integration test. So the basic idea is that you're going to create a directory to house your test. Try to name it appropriately, something that a future developer will understand what it's doing. Write IDL if needed. We highly suggest not writing IDL if you can, if it's not important. There's a lot of other IDL libraries that are already compiled, and those can be shared among tests, and that helps build time and size and a variety of other things. And the deadline test has an example usage that uses the consolidated messenger IDL. You're then going to write a C++ program for the different participants. And if you're doing this in Java, it's going to follow a similar pattern. You'll then write an MPC file that compiles the IDL in C++. You'll then write a driver script called run test PL. And again, there's examples of all of this in this hello world. So I'm going to skip the details. But your driver is going to add libraries, form command lines, and then it's going to combine exit statuses to determine your overall pass-fail. Then, and this is a very important part that I typically forget, that it's add your test to the list of automated tests. So there's a file called test/dcps-test.lst. There's a couple of these, but this is the main one. And each line has a command line and then some configuration flags. So for the deadline test, we have these, it's run twice, one without parameters and then one with RTPS_disk. And these things to the right of it tell you certain features. So in this particular case, we're not using the minimum profile and we're not using the safety profile for the first one. The second one says we're not using the minimum, and it's not no multicast, which means multicast is there, and it's only run with RTPS, or it had to have an RTPS build. So if you want to see the list of all of the configs, you can run this auto run test command, and that'll show you all the configs. And then finally, write a README to communicate to future developers kind of the high level structure of the test, why it does what it does, and any hints that you have as that you came across when you were developing. Okay, so some hints when writing an integration test. The biggest problem when writing tests is coordinating multiple processes. So when possible, we suggest a single process test, where in a single process, you can spin up multiple participants and data readers and data writers, and you can use locks, condition variables, semaphores, all of the standard concurrent programming techniques to do your coordination. And they're just easier to debug. You only have to load your one executable in the debugger, and then you have access to everything. Another thing to make your life easier as a contributor is to use reliability policy and other features to your advantage. So if you're sending messages and counting them and there's no reason to not have reliability on, then you should use reliability. You need to be aware that some features are not implemented in all transports. For example, wait for acknowledgements doesn't work in the multicast transport. It will say that everything is great, but it really doesn't do anything. So there are certain gotchas like that. So be aware that you may be running into a problem where the feature that you're testing in combination with a transport that you're using may not work the way you expect it. Another problem is do not sleep. So, or at least try your hardest not to. So there's a lot of utilities for publishers and subscribers where you can wait on subscribers to match or publishers to match or a sample to arrive. Using those utilities makes the test a lot clearer, shorter, and it just generally improves the quality of the test. There's another helper class called the distributed condition set, which essentially allows processes to say that they've reached a certain point, and then another process can check that it has, and then they can mutually proceed. And that can be done via in-memory communication, or it can also use a file system to implement that. And then when you're writing your run test PL, use the test framework Perl module. It does a lot of the heavy lifting in terms of configuring things and starting processes and shutting them down in a cross-platform or a platform-independent way. So it is definitely a good feature to use. And finally, assume your test will be running on an overutilized and underpowered VM, because it will. To run integration tests, you in the test directory, you can do run test, you can pass config flags, although it's typically not necessary if you're kind of testing what you're building, and then any arguments. If you want to run all the tests, you can run this auto run tests, again, with any of the flags that you want to pass, and it will run the entire test battery. One more thing on the linter, there is a lint script which checks certain aspects of coding style. If you want to run it, there's the command there. So I introduced a tab into a header file and ran it, and you see this kind of output. So the linter is going to complain that, try to give you a good reason for the problem that it's found, and try to tell you where it is so that you can go in and fix it. So you'll typically see that in the CI and GitHub Actions, and then you can take a corrective action.
Thanks, Justin. So I'm going to talk a little bit about where you might get started. And so obviously when you contribute code to OpenDDS, you're going to be opening a pull request on GitHub. That's where we host everything. But you may be wondering where, what we even need done, or how you can contribute, what's a good idea. You may have your own ideas, but there are a list of other ideas that are out there already. We mainly look at the GitHub issues in terms of engagement with the community for what's out there. A lot of these have been labeled. And so specifically, if you're looking for something easy to kind of, dip your toes in the water, you can look for the beginner label. And then, that goes all the way up through intermediate advanced. Sometimes they're bug fixes, sometimes they're feature enhancements, sometimes it's like general code cleanup, maybe getting things up to date with our, our development guidelines, or moving from an old style of doing output to a new style, something like that. All the way down to, we need features added. We just talked about one, right? Which is the wait for ACK for the multicast transport. That's not a place that I would recommend that anybody looks. And that's one of the reasons, maybe if you have your own ideas about what needs to be added, you should create an issue for it first if it's not already there. And that way, the rest of the OpenDDS team and contributors can take a look, and we can help you to, prioritize what changes actually are needed and which ones might not be a good idea because, those features might be going away in a future version or something like that. If you just have general questions or want to start up general discussions about what new features or a roadmap might be good for OpenDDS, that's where the GitHub discussions probably comes in. Really, those discussions can take place in issues or discussions. It's, we'll look at both of them. And then lastly, as you're trying to figure out, what changes you might be interested in making, it's also good to just review the other pull requests just to make sure, that you're not going to be stepping on toes with another developer who's trying to solve a same or similar problem. Maybe you ought to build off of their branch. Maybe you ought to wait until their changes are done, or maybe they've already looked at the issue that you're planning on doing and they've already made some changes towards that. And so it might be good for you to either wait or pick a different issue to take a look at. This isn't meant to be a full-blown in-depth discussion of how to use Git or GitHub. Hopefully you are at least a bit familiar with both of these. This is just a general outline of our kind of workflow. I'll say my general workflow for submitting a PR. There are other ways of doing some of these commands. For example, in setting up the build environment, above Sun gave a different command for cloning GitHub where we used the HTTPS instead of Git, and that either one of those is fine for this step. But when you're if you go to fork GitHub, that fork our repository, and you're going to add it as a remote so that you can push branches to it, you're going to need something where you have write access. So this is one of those reasons why you might be using the Git URL as opposed to the HTTPS URL. So for this, the general workflow is, you clone, configure, you build OpenDDS, you set up your development environment. You'll want to fork the OpenDDS repository on GitHub. You only have to do this once. So if you've already done it, you just need to add the remote to your local clone, and then you'll create a new branch based on master. And so you probably want to do a pull just to update master, and then you create a branch where you can do your work. Then you modify all the code to do whatever changes you're trying to do, and you'll test it with if you're just modifying a single test, you can just run that test. If you're modifying part of the core library, maybe you need to run many tests, and you can use test scripts that Justin talked about. But then eventually you're going to commit these changes, and maybe that's several commits, but we appreciate helpful descriptions in the change requests. Make sure that your name and your email are correct in your Git config when you're doing this, so that the commit history is correct, and you get credit for your good work. And then you can push that branch, the changes from your branch, into the fork of your repository. So in this case, because the remote is named mine, you just push to mine and the name of the branch you created. And if it's the first time you've pushed, Git will spit out a link, and you can either follow that link to make a PR, or if it's you can navigate through GitHub directly and create a pull request trying to merge from your branch into OpenDDS master. And when you do this, you're going to fill out a description for your PR, and all of the many build CI steps are going to get kicked off. I think there's something like 130 steps. A lot of them are just kind of blinking in versions of ACE and DAO, but then there's at least 20 or so different build and test runs that are testing out the code that you're trying to submit. And so we want to talk a little bit about what some of these CI results look like, just because there's a lot there and it might be a little confusing. At the bottom of the pull request page, you'll see something. First, you'll have to get approved for the CI to run, but then once it's running, some of the checks, it'll report back on a bunch of the checks that are run. And so the main categories of checks are you'll see in this image here, there's linting, and that Justin talked about how you can run the lint script itself outside of the CI. There's also Sphinx is just making sure that it can update and build some of the documentation. And then there's this build and test check, which is what's launching all of the various builds and tests of OpenDDS. So the most common things you're going to run into here, the check mark at the bottom of the image tells us that there's no merge conflict, but you might actually have a merge conflict. If that's the case, there's a couple of ways to resolve that. This is maybe a place where you Google how you resolve merge conflicts with Git. The easiest ones are probably to either merge the master branch, or if you don't want to add a merge commit, you can try to rebase if you're feeling advanced in your Git usage. Lint failures we already talked about. Hopefully you can, if there's an X next to the lint CI, you can just click on the details and you'll get details about what needs to get fixed and what files and their locations. All that should show up in the CI. And then there's build and test failures. So on the next slide, I've got an example of a build failure. You'll have a red X, on that main page, but if you click it, it's going to bring you to a page that looks like this, and it'll show you the name of the build that failed. That's the red X on the left, and then it'll show you the make OpenDDS build step will have an X, and if you scroll down, eventually you'll see, what thing this particular build with this particular compiler on this particular machine is complaining about. If it doesn't fail for you on your machine locally, you may need to try and set up a build that looks like what this one does. So if you edit the build and test workflow file, or if you go look at it in GitHub, in the repository under the .github, there's a workflow file called build and test, and that is where you can see what parameters are actually being used for this build. And we tried to have shorthand hints in the name of the build here. So this one in particular is the U18 stands for Ubuntu 18, and it's optimized, debugging is turned off, and it's using versioned namespaces. You'll have to work through what failures you're seeing in the build. For the next slide, you may actually encounter a test failure where everything builds, but the test actually fails. here you can click on the details next to the failed test, and it should take you to the check results tab for that particular job. And it will spit out the error messages that go along with the failed test. Here, if you went and ran the same test locally, this is hopefully what you'd be seeing for the failure. Again, if it doesn't fail exactly the same way as it, if it doesn't fail in your machine, you may need to set up some environment where you can duplicate what's being failed. This is also a place, I chose this test in particular because this is a test that intermittently fails for every PR at the moment, and that's one where we will eventually clean up, but currently it's just a known failure. So anytime you hit a failed test like this, especially if it's something that you don't think is related to the code that you changed, it's always good to check in with the other developers and just to make sure, is this actually a test that I need to take a look at and fix, or is this something that we know about and might be resolved in another ticket, another issue, another time, and that the reviewers will help you obviously identify which one's which. So assuming you get through review, you resolved all the review comments from the other developers and the CI looks good, we'll merge it. And then there's maybe two things to think about after the merge. We also have the OpenDDS scoreboard, which only runs against what's been merged into master. And this is a set of VMs that are not hosted by GitHub. These are hosted by OCI and a few other companies. These may have special configurations that they are not as easy to duplicate the GitHub Actions environment, or they may just have pre-existed. We have, for example, we have an Android build, and we have, I think we have a Raspberry Pi cross-compile build as well. And the other thing is the performance dashboard, where we run some of our performance tests against the code that comes off of master. This takes several hours to update, but after your PR has been merged, you can check back maybe the next day, and you can see if what's been merged has had any significant impact on the performance numbers coming out of the performance dashboard. And that's all I wanted to talk about for making a PR. And I think Fred is going to talk a little bit about documentation next.
So we're running out of time, so I'll try to be quick about this. Developer's Guide, which was mentioned earlier, it's the user-facing documentation. We don't have a direct way to contribute to it at the moment. So the best way to point out an error or maybe suggest some changes is probably to open a issue or discussion on GitHub or bring it up in the mailing list. The other thing, it's been referenced throughout the presentation, is the Sphinx documentation. This is what's located in the docs. I don't have it here at the moment, but it's hosted on Read the Docs as well, as you can look at the files directly in the repo. It uses the Sphinx documentation framework, and it's written in restructured text. And in addition to it being hosted, you can also build the hosted version locally using the build script that's in the docs repo. And hopefully in the future we'll do more of this, more with this, but for now it just has more internal stuff that we've been referencing, like the documentation for unit tests and the developer guidelines. The other thing that's also been mentioned is the website. I think Adam mentioned it's on the branch, and that is the GH Pages branch. It uses the Jekyll static website generator, and its content is written in HTML for like the menu parts and the templates, and Markdown for, I think, most of the actual content. So that's pretty nice. And like the Sphinx documentation, it can also be built and served locally. You can see the README in that branch if you want to know how to do that. And then the other thing I was going to talk about was contributing to things that aren't OpenDDS directly. The first thing is NPCs. Sean talked a lot about this, so I won't talk much about it, but it's the build system. It's written in Perl, and I don't have the URL up here, but it's hosted in the doc group, GitHub group. One important thing to note is that it has the Visual Studio part that we use, but the generation that's used on Mac OS and Linux called GNU's, its specific implementation is actually in ASTOW under certain URL that I don't think I have written down here, but you should be able to find it. ASTOW itself is also in doc group. It consists of ACE. It's the platform used for networking and event loops like Reactor, which is what reacts to incoming network events. And then DAO is a C++ Corba implementation. It's used for IDL. So like DAO IDL and OpenDDS IDL is built off of DAO IDL. And then the C++ mapping, that's not, say, the C++11 mapping that resides in DAO. And then typo here, doesn't have info repo discovery. It has the org that we use for info repo discovery to actually do the actual Corba stuff to coordinate discovery across participants that are using info repo discovery. And then finally, there are various repositories that extend the OpenDDS in other languages. First one is Node OpenDDS. It allows you to run in JavaScript on Node.js. And then there's PyOpenDDS. It allows you to do the same with Python. And both those are in the OCI Labs GitHub account. And then OpenDDS Sharp is a little different in that OCI hasn't developed it, maintained it itself. Third party has started it, but it has our seal of approval. We've worked with it a bit, and it allows you to do the same with C#.
All right, thanks guys. That was awesome. So I think we're right at the top of the hour. I'm gonna I don't believe that we have any questions in the Q&A. So if anyone has any questions, please go ahead and put them in the Q&A now. The guys can hang out for another minute or so. Thank you all for joining us. If you do have to go, we really appreciate your time. And if you can't stay, please do go ahead and you can email us questions and we'll get those answered for you. If anyone has any time to stay, like I said, the guys can stay for a minute or so and we can answer those questions live. Yes, so we will, we did record this and we will provide the recording. So we'll go ahead and send that out. Since you register, you'll get a copy of the recording and we will also publish it online. So you will get a copy of that. All right, well, if that is all the questions, thanks again for joining us and we'll see you at our next webinar. And we do have some upcoming training events coming up here in the next couple weeks. So if you, I think we had the links earlier in the slide deck. You don't have to go all the way back to the beginning, but so they will have those provided with the recording, but and you can also find them online. But we do have some training out there. Thank you so much. The first part of July, we've got Introduction to OpenDDS Programming available in C++ and Java, building OpenDDS applications with DDS security, OpenDDS Essentials 1 and 2. So we would love to have you all join us and we will see you at our next event. Thank you all.